Thanks for coming back. Not like you had a choice if you're in my class anyways. Here we're at section 8.3. We're going to talk about the laws of logarithms. This section is kind of tough, and I know when I was learning this stuff back in grade whatever it was when I learned this is where I had some problem. So hopefully you won't suffer the same fate as I did. Hopefully that I'll teach it to you better. So, just like how there are exponential laws, there are also logarithm laws. But once again, recall how logarithms are really just exponents or exponentials. So, these two types of laws should be similar. Hopefully you can kind of see the similarity. And then in example number 1, I'm going to show you or prove to you why the log rules are the log rules. So, let's go back and do the exponentials first, because I know you have a good memory. And there's the product rule, where if I have the base being the same, in both of these cases it's x and x, and the exponents are m and n, what do we do when we multiply? That's right, we add them. So m plus n. Division, well, we're going to divide, and of course, if you remember correctly, we subtract them. And then we have powers, so m to the power of n like that. We then do just x to the power of m times n. We multiply them. So what do you think's going to happen with logarithms? Okay. By the way, let's change this to base c. Okay, just base c, because we're used to doing base c, not base b. Well, with logarithms, what should you expect if you have multiplication? Well, just like the exponentials, remember logs are the exponents. Well, it seems like the exponentials you added, so if you guess that we do log base c m plus log base c n, you are correct. And I'll prove that to you in example number 1. For division, you should have correctly guessed that it's log base c m. Take away log base c n. And what about this one with the powers? Remember, it's multiplication. So the logarithm rule says that you can take the power, which is n, and multiply it. So it's n times log base c m. Those are the log rules. Let me prove them to you, just so that you know I'm not lying. Not that I would lie to you anyways, but I don't want to be called a liar, so I'm going to prove it to you. So, example number 1, I'm going to ask you to prove the product, quotient, and power laws of logs. Now, what I'm going to do is let log base cm equals to this number, which we call x, and log base cn equal to this number, which we call y. I'm going to ask you to rewrite these in exponential form first. So this becomes c to the power of x equals to m, and this one becomes c to the power of y equals to n. So now for the product law, it's m times n. M would be c to the power x. N is going to be c to the power y. So notice m times n equals to c excuse me, to the power of x times c to the power y, which of course just equals to c to the power of x plus y. Okay. And if I now ask you to now take this and now use this expression and convert to log form, let's see what you get. You'd have log base c, and you'd have the number mn, and that would be equal to your exponent, x plus y. Well, what's x and y again? Oh yeah, look back up here and we found that x was just equal to log base cm, and y is log base cn. And there you have it, your product law. Okay. Now, the quotient law is the exact same way, so I'm going to let you try that one out on your own. Okay? Try it. Exactly the same. steps are the same, like what I said to you. They're the same. In this case, I want m divided by n, so that we c to the power x divided by c to the power y, which of course, when we do exponents, we subtract. So therefore, what we have now is m over n equals to c to the power x minus y. This is the expression now that I want you to now change or convert to log form. So log base c m over n equals to x minus y. And lo and behold, we're going to make the substitution from above again. So here we go. We have log base c m minus log base c n. And you got it. That's the same as the division. Ta-da! And last but not least, we're going to use the power law proof. And I'll use purple for that. Same thing, first of all. Let's rewrite this in exponential form. Now, in this case, we have here raising to the power. So I'm going to take this now, and I'm going to raise both sides to the power of n. So what I mean by that is I'm going to take this and raise the power n, take this to raise the power n. So now we have c x n equals to m to the power of n. Once again, at this stage, I like to see if you can change this into log form. So convert to log form. So log base c, and it'd be m to the power n equals to the exponent x times n. Of course, x once again is what? Well, x was just that up top. So I'm going to rewrite this as, I'm going to put the n in front first, and then the x will be here. The x is just log base c m. So therefore, we've got log base c m to the power n equals to n times log base c m. Ta-da! Our proof of the third law. Now, if you don't like proofs, then don't worry about it. But, once again, just want to show you that Mr. Lee does not lie to you about math. Alright, the key thing is to know these three expressions and now know how to use them. So in example number 2, I'm going to ask you to express each expression in terms of individual logarithms. So I've got this nice compact log, but I want you to separate them into individual logs using the product, quotient, and power law. Okay? So if you look at the first example, log base 4, we've got AB over C. Well, AB is multiplication, C is division. So I think what I'm going to do first is going to rewrite this as log base 4. You see AB as one term. And because I see division, I'm going to use that quotient law. So there's my first part. And I'm going to subtract that from the next part, log base 4C. Okay? This is still not good enough because I want individual logarithms. AB is not an individual logarithm. AB seems to be multiplication, so I can rewrite this using the product law. And that will be just log base 4a plus log base 4b. I'm just going to copy down the minus log base 4c. And there you have it. Individual logs. This is the correct simplified expression. Okay? Do the same thing for now part B and part C. Okay? I'm going to ask you to try these on your own. Okay, maybe I'll do part B with you and then let you try C. Okay, so part B, division, right? So okay, log base 9 1, take away log base 9 n cubed. Log base 9 of 1. Remember, if I were to ask you to evaluate this, that's in exponential form. Let me just kind of do it over here. That'd be 9 to the power of something gives you 1. Well, what exponent will be giving you 1 is the exponent 0. So that's just 0. So 0 minus log base 9 n cubed. This is not an individual log because you got that cube. Notice we've got power here, so I can use the power rule now. Or not the power rule, but the power law, and then take that 3 and bring it down in front. So negative 3 log base 9 n. That would be the answer. Okay? All right. You try part C, please, on your own. If you did division, I'm happy. If you then saw the multiplication, I'm happy. Then I'm thinking this cube root we can change. So let me just rewrite this. I want to change it to a power. How about z to the power 1/3? And now we've got these powers. We can now rewrite them using the power law. We'll bring the exponents of the power down. So 4 log x's. You got 2 log y's. And you got minus 1/3 of the log z. Done. Okay. I can ask you to do the same thing now. In this case, I want you to simplify them into one logarithm. So let's make something complicated look easy. And then hopefully after one logarithm, you can simplify. So you try the first one. I think it's pretty straightforward. So is part B. I think the only one that's really hard is part C. So I'm going to ask you to try A and B. Go! Did you do part A yet? I said try on your own. Don't wait for me. Minus. Oh yeah, what could that be? Oh yeah, minus is the same thing as division. So that's 50 divided by 2. Oh yeah, well that's the same thing as 50 divided by 2 is 25. Oh yeah, this looks interesting. Remember, one logarithm, maybe I'll call this x. I can change into exponential form. Or just know this by heart. Which exponent? 5 raised to what exponent is equal to 25? Yeah, I think x equals to 2. So your answer is just 2. Okay? So your expression here just equals to 2. Whee. Okay, next one. Multiplication. Once again, you can make this equal to x, change into exponential form. That's, I think, to the power 7, so x equal to 7, so this whole thing just equals to 7. Excuse me. Last one's a little more difficult, because there's more things, but nonetheless, I would think, let's combine those together. So log base 4, 5a and 8a cubed. That just becomes 40a to the power 4. We got minus log 4, 10a to the power 4. Of course, the subtraction here means we can do division. So log base 4, 40a to the power 4 divided by 10a to the power 4. Lovely that the a to the power 4 cancels out, and 40 divided by 10 just gives you 4. So you have log base 4, and I'm not going to change this to exponential form because I know this just equals to 1. Yeah. Right, turn the page. Oh, one more of these. Okay, so why don't you try, maybe I'll do this one with you because There's some interesting thing in this one. Notice there are coefficients in front of the logs. Ew, ew, ew. So perhaps we want to get rid of them somehow using that power rule, because multiplication was the exponent, so we can actually bring this up into the exponent. So watch what I mean. Log base 6, 3 to the power of 3, plus log base 6, 2 to the power of 2, plus log base 6, 4 to the power of 1/2. Okay? And then we can just evaluate those things first of all. 3 cubed, I think, is just 27. 2 squared is 4. And 4 to the power of 1/2, that's like the square root of 4, that's just equal to 2. This is all plus, so I guess we can just multiply them together. So 27 times 4, what's that, 108. Log base 6, 108. And then we have still log base 6, 2. By the way, we can only do this when the logs are the same. If they're not the same, we can't combine them together. But these cases, they are. So that's log 6216. And if I wanted to actually evaluate this, I'm going to change into exponential form to evaluate. My base is 6. Don't know my exponent. That's what I'm trying to solve for. That equals to 216. I think 216 is 6 times 6, which is 36 times 6, so that's 6 cubed. So therefore x, of course, equals to 3. Or, just knowing log base 216, that just equals to the number 3. And that's your final answer. Okay. Example number 4 is more evaluating, so you're going to find the answer here. Sometimes you want to split things up to make things easier for you. Then you have to evaluate. So I think that's what we're going to have to do with this nasty beast. Okay. So I got log base 5 of this 25 times root 125. If I see multiplication, that should be a hint to split it up into addition of 2 logs. So log base 5 25 plus log base 5 root 125. Okay. I've got this minus sign, so I'm going to say minus, and then I still see multiplication here, so I'm going to put a bracket around this. How about log base 3 81? And because this is multiplication here, I'm going to put a plus. Log base 3, the cube root of 243. Alright, it's time, I think, to evaluate these things. I think I'm going to change those roots first into powers. So log base 5 25. This is log base 5 125 to the power of 1/2 minus log base 3 81 plus log base 3 243 raised to the power of 1/3. Those powers can then be brought down, and I think I can start evaluating. So maybe what I'll do, I won't evaluate yet, but I will bring them down using the power rule. So 1/2 log base 5 125. Take away bracket log base 3 81. Bring the 1/3 down. Log base 3 243. And here you have to go ahead and evaluate. So go ahead and do that. You can change everything to exponential form if you wish, but I know that the exponent for this one, for log base 525, so 5 to the power of what gives you 25, it's 2. For the log 5 125, that means 5 to the power of what gives you 125. I know that's 3. And by the way, this is why you need to know your exponents well, okay? Back in chapter 7, I have to memorize those exponents. Now you know why. 3 to the power, I believe, is 4, so that's 81. And 243, I think that's to the power of 5. So that's 1/3 times 5. Okay? Let's continue to try to simplify here. That's just 2 plus 3 over 2 minus 4 plus 5 over 3. Let's go ahead and now evaluate this. I'm going to make this all over, what, 6, I guess, common denominator. That's 12. 2 times 3 is 6. 3 times 3 is 9. 24. How about 10 over 6? 12 plus 9, that's 21. Take away 24, negative 3. Plus 10. What's negative 3? Plus 10. How about 7? Okay, so that whole expression just equals to 7 over 6. There you go. Last one, example number 5. Here I'm going to ask you to simplify. I want you to write each expression as a single logarithm and also state some restrictions on the variables. Okay? We'll take a look at the restrictions first. In this case, for part A, we got to make sure that all the variables, the log part, of course, x has to be bigger than 0. So if I look at this one here, that means x cubed has to be bigger than 0. Not bigger equal to, just bigger than. So of course that just simplifies x is bigger than 0. Looking at these other ones here, well, that's just x by itself, so x must be bigger than 0. What's the overall restriction since both of them are x is bigger than 0? Well, how about x is bigger than 0? That's the overall restriction for our answer. Okay, so now how do we actually simplify this into a single logarithm? I want you to make sure you can put all this together into one single logarithm. Well, if you look at the first two terms, I see subtraction, so that becomes division. So that's log base 4, and that's x cubed over x. We still have this 9 over 2 log base 4x. We're going to simplify this then to become, I think x cubed and x simplifies. That's x squared. And then I'm going to actually take this coefficient in front and bring it back up to the power, because then I have log base 4 of stuff. And notice, maybe, oops, you know what, I don't think I should have done that, because we can't really add them together like that. So, maybe instead of bringing the exponent up, I should backtrack. And let me erase. The reason why I don't want to bring the exponent up is because now I can't simplify things. What's taking so long to erase? Erase. Erase. Okay. So let's keep this as 9 over 2 log base 4x. Okay. What I am going to do now is actually ask you to take the exponent, the x squared, and bring that to the front. Because I want to write it as one single logarithm, meaning I want to be able to put them together into one thing. And so I don't need to use any of these laws to simplify any further. So if I bring the exponent down, that's 2 log base 4x. I'm going to add that to 9 over 2 log base 4x. And you see how you have like terms now? You see the log base 4x and the log base 4x, they're the same thing. So just like algebra, you add them together. So 2 plus 9 over 2, that's 4.5 plus 2, that's 6.5, or 13 over 2. So that's 13 over 2 log base 4x. And your restriction here is x is greater than 0. Done. I'm going to also ask you now to try part B, where you have some more complicated things, but the idea is the same. So I'm going to ask you to first of all look at the restrictions. Remember, the stuff inside the bracket there has to be bigger than 0. So let me look at 8x squared minus 32. That has to be bigger than 0. I'm going to factor out the 8. Don't know if you remember how to do this kind of stuff. 32 8 is 4. I'm going to factor this difference of squares. Remember that lovely stuff? Remember, you're supposed to solve for x, so you get x equals to -2 and x equals to 2, and then you drew that number line. This is grade 11 stuff, grade 11, chapter 9. Watch my videos if you don't remember. Even if you don't remember, this, hopefully you remember as what type of shape is this? This is the parabola that opens upwards, so it looks like this. So where's the graph bigger than 0? Well, that's of course where the graph is above the x-axis. That'd be over here and over here. So your regions that make 8x squared minus 32 be bigger than 0 is that your x values has to be bigger than 2 or less than -2. So those are your restrictions from the first bracket. Oh man, you gotta do the same thing for the other one. Oh, nasty. Oh, by the way, I think this should be a plus sign. Change your notes to a plus sign here. Okay, plus. So, gotta do it for the other one too. Oh, nasty, nasty, nasty. This is just all restriction stuff, eh? So, okay, so x squared minus 6x plus 8. That has to be bigger than 0. Oh boy, more factoring here. Find two numbers that multiply to 8, add to -6. Good old factoring. X minus 4, x minus 2. Of course, that becomes x equals to 4, x equals to 2. Draw my number line, 2 and 4. I know this is a parabola too that opens upwards, so of course the region where it's bigger than 0 is this part, x is bigger than 4, and this part, x is less than 2. Now, take a look at all these pieces, okay, of the restrictions. I'm going to highlight those in blue. This one, this one, this one, this one. I need you to tell me what is the overall conditions, okay, to make this work. So my question to you is, what conditions allow all these conditions here that I've circled to hold? If you look at the less than stuff, well, the one from the top here says that x must be less than -2, okay? And this one says x is less than 2. Which one's the one that's more restrictive? Yeah, it's x is less than -2. So that's the one I'm going to use, okay? Because that's the one that satisfies both of these. And looking at the greater than, so you got x is greater than 2 and you've got x is greater than 4. Which one of those two restrictions satisfies both? Well, it's x is greater than 4, so I'm going to use that as my restriction, because that one satisfies both pieces. So this is my overall restriction, okay? The restriction that works overall. Okay, all that worked just for the restrictions. You still haven't actually simplified. Let's go back and simplify, all right? Well, to simplify, I see subtraction, so I guess we're going to be doing some division. You'll see that we did all that factoring there, hey? Yeah, that's going to come in nice and handy now, because leave factoring, I'm going to use it. The 8x squared minus 32, we factored that into 8 with an x minus 2 and an x plus 2. At the bottom, we factored that into an x minus 4 and an x minus 2. So I hope you can see that something cancels, or divides out, I should say. And we have log base 8, got an 8 with an x plus 2 on the top, and an x minus 4 on the bottom. Once again, we need to simplify this. I see some multiplication and some division. Well, let's do the division part first. So that's 8 with an x plus 2. I'm going to subtract from that log base 8 with an x minus 4. Continuing on, we can split up that first part, log base 8, 8, plus log base 8 x plus 2, minus log base 8 x minus 4. And one last thing I can do to try to simplify this, log base 8, 8 is just 1. So we go 1 plus log base 8x plus 2 minus log base 8x minus 4. And with the overall restriction that I've already put in the cloud, there you go. Done simplifying. All right. I think we're good.